everyone, it's Justin again. In this lesson, we're going to identify key information for circles from their general form equation. In order to do this, we're going to turn the general form equation into the standard form. And then we'll identify the circle's center and radius from there. We're taking skills you've already learned in this unit and putting them together. So if you're not confident in your skills in these areas, you'll want to go back to review before continuing with this lesson. By the end of this lesson, you will be able to identify the center and radius of a circle when given its equation in general form. You've already learned all the skills you need to be able to do this throughout the unit, so in this lesson, we're going to take those skills and use them to complete 2 example problems. Our first example asks us to identify the center and radius of a circle with the given equation. We're given this circle equation in general form. Does this form tell us the center and radius? It doesn't, but what form does? That's right, we have to rewrite it in standard form. Remember, standard form looks like this. Let's see if you can use what you've learned in this unit to rewrite this in standard form and then identify the center and radius. Pause the video now and try to complete this problem all by yourself. To figure out both of these parts of the equation, we need a completed square for x and y. In order to get ready to complete the square twice, we need to do some rearranging. We want the terms with x together in the front. This time, there's only one term containing x, so we're just going to write that. Since there's only an x squared term, we already have a perfect square. Normally, we would put a blank on each side of the equation to fill in when we complete the square for the x terms, but we can skip this since x squared is already a square. Then we can place our terms with y next, and we'll put a blank on each side of the equation for when we complete the square for our y terms. And finally, we need to move the constant to the other side of the equation. And remember, to do this, we have to change the sign, so -7 becomes +7. If you made any mistakes up to this point, just keep going from here. Try to complete the square for the y terms in order to figure out this part of our standard form equation. Then write the standard form and find the center and radius. Pause the video and try this on your own. You should have filled this in using the terms with y in them from the equation. Remember, the -6y gets split evenly to get -3y for 2 of the boxes. And the new number we had to add in was -3 times -3, which is +9. We have to add 9 to both sides of our equation to keep it balanced. Then we rewrite the expression from the orange box as a binomial squared. Since we had this binomial times itself, that is the same thing as squaring it. Okay, so we just finished completing the square, and we almost have our equation in standard form like we want, but there is one final thing left to do. We need to add these 2 numbers together to know that our radius squared is 16. Now that we have this in standard form, can you tell what the center and radius are by looking at this form of the equation? Since we don't see an h term, that just means it's 0. We can see that the k term is 3, and that gives us the center at 0, 3. Then we can take the root of 16 to see that the radius of the circle is 4. And now that we've found what we're looking for, we have our final answer. Our last example also asks us to identify the center and diameter of a circle with the given equation. I want you to complete this problem all the way from start to finish by yourself. If you can do this 100% on your own, we'll know that you're ready for the practice game for this lesson. Pause the video now to try this out. Are you ready to check your work with mine? Standard form will tell us the center and radius, and the radius can just be doubled to get the diameter. So let's change this equation from general form to standard form. To figure out both of these parts of the equation, we might have to complete the square twice. Once for x and once for y. Unless we run into a situation like in our previous example problem, where we only had to complete the square once. Let's do some rearranging. We want the terms with x together in the front. Then we put a blank on each side of the equation to fill in later when we need to complete the square for the x terms. Then we can place our terms with y next. And since we only have the y squared term, we do not have to complete the square for y. It turns out that this is another example where we only have to complete the square once. And finally, we need to move the constant to the other side of the equation. And negative 12 will become positive 12. Then we can complete the square for x, so you can figure out what will go into both of these blanks. We fill the terms with x into these boxes. I evenly split up the 8x into these two boxes. Then I worked backwards to fill in these binomials. And remember, these binomials have to match each other since the goal is to be able to write a binomial squared. Then we have to fill in the final box. Positive 4 times positive 4 gives us positive 16. Since we had to add that in ourselves, we have to add it to both sides of this equation. Then we rewrite our completed square in this form as a binomial squared. This binomial was multiplied by itself, which is the same thing as squaring it. Then, since we figured out earlier that the y term is already a complete square, we just have to copy that into its correct location. Finally, we add the terms onto the right side of the equation. 12 plus 16 is 28. Now that we have this in standard form, can you tell what the center and diameter are by looking at this form of the equation? The h term is negative 4. And since we don't have a k term, it's just 0. That gives us the center at negative 4, 0. Then we can take the square root of 28 as the radius. And remember to simplify it if possible. Since 28 is 4 times 7, we'll have 2 root 7 as the simplified radius. Then we just have to multiply it times 2 for the length of the diameter, since a diameter is always twice as long as a radius. 2 root 7 times 2 is 4 root 7. Now that we've found what we were looking for, we have our final answer. That's it for this lesson. Remember that general form doesn't show us the center and radius. So if you're given general form, be sure to switch it over to standard form so that you can identify them. See you next time. Hey.